In this video, we're going to look at Unit 7, Day 4, how to solve exponential and logarithmic equations. Recall that we introduced this new function, a log or logarithm, as the inverse of the base of a power. So in these first two pieces here, we're describing the property of equality for exponential equations, where this is going to explain that if you have an equation, bx equals b to the y, really what you're looking at is the base of the powers are exactly the same. So if you took the same log of both sides, you'd only be left with the exponents. So then an example with numbers here that might make it a little bit more clear is look at how we have 3 to the power of x equals 3 to the power of 5. Well, if the bases are the same, essentially what you would do to get the x by itself is take the log base 3 of both sides, because we want to keep it balanced. So the log would cancel with the base on the left, and the log would cancel with the base on the right. So all you were left with is x equals 5, x being the exponent from the first power and 5 being the exponent from the second power. The reverse scenario also holds true. So if you start with x equals 5, you can essentially make these number 3s any base number you want as long as they match the equation to hold true. All right, so how do we apply this? So we're going to look at an exponential equation and try to solve it. And what we're not going to do is use a calculator in this problem here, because we're not going to need to. This example up above, this property, what it shows you is all you have to do is make sure the bases of the powers are the same, and then really just cancel them out and solve the equation that's left with the exponents. So right now we have two different bases. We have a 4 base on the left and a 1/2 base on the right. So we have to think to ourselves, how do we make the base of the power on each side of the equation match? This could mean that you leave one base alone and you change the other base in order to match it, or in certain cases, more complicated cases, you might need to adjust or manipulate both bases to make them look the same. So what you want to focus on is how can we rewrite the number 4 and possibly the number 1/2 so that they look like powers with the same base number. So since this is an example, I'm just going to go ahead and go for it. The number 4 can be rewritten as 2 squared. We're going to keep the x that was there from the beginning. The number 1/2 can be rewritten as the same base 2. Can you guess the exponent? -1. And then we're going to keep the x minus 3 that was there from the beginning. So to review, all we did was change the 4 into 2 squared and the 1/2 into 2 to the -1st power. Because what you'll notice now is you have bases that match. Now we're not going to jump the gun and cancel them out right away. We're going to make sure we take the exponent, the 2, and the -1 and distribute those, multiply those, or combine those with the exponents that were there originally. So I'm going to rewrite this one more time before we address the bases. So this is really 2 to the 2x power, and then the right side is base 2 to the -x plus 3 power. We're going to distribute the -1. Now, essentially, mathematically, what you're doing is we're going to take log base 2 of both sides. You do not have to show this every time. You can skip right to bringing down the exponents and solve that equation as it remains. 2x equals -x plus 3. So now you have a just very simple algebra 1 equation to solve to finish this off. So if we add an x, we get 3x equals 3. So x equals 1. All right, so as we move on to the practice problems, your goal here is to do the same. If you look, I'll give you a hint for the first one. If you look at the bases, right now you have a base of 100 and a base of 1000. the idea is to rewrite them so they have the same base to whatever exponent is required. So if I do one step of this one for you, I'll have you finish the rest. 100 and 1000 can each be rewritten as a power with a base of 10. So 10 to what power gives you 100? 10 to the second power. Keep the original exponent. 1000 is 10 to the third power. Keep the original exponent. All right, I want you to continue that problem from there, and you can check the answer key to see how you did. The one to the right, the number 3 at the base on the left, that can't be rewritten as any other number smaller than it to a power. So that's going to be a hint to you that you're going to leave the number 3 alone and try to rewrite 243 as a power 3 to some exponent. And you're going to have to figure out what that exponent is and then continue from there. You can check the answer key when you're done. All right, as we look at the next set here, this one's going to get a little bit more complicated just because there's an extra step at the beginning. If you notice the difference in this example, there's 2 powers on one side of the equal sign, whereas the ones above was just 1 power equal to another power. So if you read the directions, this says when there is more than 1 power involved on one side of the equal sign, make sure you condense the expressions on each side into one single power before solving. So what we're going to have to do is call upon what we learned last lesson, and we're going to have to condense or put together these 2 exponents on the left. And it's not condensing like we learned with logs, but it's using our exponent rules that we've learned from the past. Now what we're going to have to do first is still manipulate the bases so that they're the same, because in order to combine powers you have to have the same base. So 1/9 and 81 can both be rewritten as a power of base 9. 1/9 is 9 to the negative first, keep the original exponent, times 81 is 9 to the second power, keep the original exponent. All right, the right side is going to remain the same. I'm not going to change anything about the right side, and if you notice, it already has that base that we're using on the left. Perfect. All right, before we can do any sort of solving, we still have to condense the left side. We got to put those 2 exponents, those 2 powers together by combining their exponents. All right, so let's go ahead and distribute the new exponent that we introduced. So this is now 9 to the positive 2x power times 9 to the 4 minus 6x power. Again, the right side stays the same. And still focusing on the left, now we can put those together as 1 power with a single base. If you recall from the prior knowledge, when you're combining powers, okay, by multiplying, we add the exponents. So this is going to be 1 base of 9, and we're going to add the exponents. I'm going to go ahead and combine like terms as I do that. So 2x is going to be combined with negative 6x to give me negative 2x, negative 4x, sorry. Let me go back and fix that. Negative 4x plus 4, and the right side still the same. But at this point, we can go ahead and cancel the base 9 on both sides and solve the equation with the exponents left over. Right, so I'm going to take that just into the blank space over here. Let's continue solving this. Let's say I'll put 6x on the right side. 2. So we'll get a fraction for this one. We'll get 1/3 in the end. If you're ever interested in checking your work, just like any other problem, take the answer you got, go back to the very beginning, plug it in everywhere you see an X, and you can use a calculator to help you with the order of operations, but just see if you get the same answer on both sides. All right, so here we have 2 examples. I'm going to let you go ahead and practice with those. Try to figure out, I think pretty easy to see what base to use on the left side. On the right side, you can look and see that, okay, here's a 2 base, Those can't be made any smaller, so that's again a hint to you, an indication to you that you're going to leave those alone and try to change 1 over 16 into a power of base 2. 2 to what power gives you 1 over 16? So again, go ahead and use those as practice, and then check with the answer key to see how you did.